What if the Earth was a cube? So for this one, we decided to make a cube that is the same volume and mass of the Earth. And for the implications of what that means, I'm going to let Ben start us off.
All right, so first off, I just want to briefly say that, so we get into some sort of wild stuff. This gets, I think, into one of the most, like, buck wild things we've ever done, honestly.
This is probably one of our most intensive questions.
Yeah. Things get a little crazy.
Yeah, mostly just because, like, the science, like, just works behind it all.
Right.
Like,
right,
you can figure out what happens, and it is wild.
Yeah, so sort of get you on the same page, like, mentally as us. Well, I don't know if you'll be on the same page mentally as us on anything, but the same idea as us. What we're looking at here is basically a cube that is about 6,300 miles per edge, so 6,300 by 6,300 by 6,300, roughly. And then, sort of to start, I don't think you understand sort of the gravity of the situation, by which I mean you don't understand how gravity works in this situation. I was very happy when I thought of that joke. Anyway.
You've been waiting this whole time.
That's a prep joke? I thought you just did that.
Nope, that is a joke that I prepped and have written out in my notes.
I thought makes it even worse. Thought of that and then said it, and then were actually secretly ashamed inside for a second, but decided to keep going.
Nope, I intentionally did that to everyone. Anyway, so sort of, when you live on a sphere, as we do, gravity is sort of constant. You are always roughly the same distance from the center of mass of the Earth on our normal spherical Earth. There are differences in gravity on Earth, but the range of altitudes the range of distances you can be at from the center of the Earth isn't that big. It's just a few miles. So you express gravity, or at least we express gravity in terms of G's, which is the, ratio to our regular Earth gravity. The range on Earth is only like 0.7% from the lowest to the highest. So a little variation, not too much. On the cube, the variance and like the distance from the center is much, much higher. So relative to like the center of one of the faces of the cube, if you were at the center of one of the edges, you are 1,300 miles further from the center. And if you're on one of the corners, you're 2,300 miles further from the center. And what that means is that, effectively, if you're at the center of one of the cube faces, gravity is about the same as Earth's gravity. If you're at the center of an edge, it's about 0.85 what Earth's gravity is. If you're at a corner, it's about 0.646 Earth's gravity. And just sort of for reference, the moon is like 0.166, so we're not talking like moon gravity, but definitely noticeable.
There's definitely a difference.
Yeah, certainly a difference.
You ever feel lighter after you take a big dump? It's like that, but
so the example
0.6 is like you take like 30 of those in a row. You just keep multiplying that feeling.
The example given is that if you weigh 200 pounds like on Earth, if you went to the corner, you would weigh about 120. So it's a great difference.
Weight loss program.
Yeah, exactly. And then the other interesting thing is that, so once again, when you're on a spherical planet like ours, the center of gravity is always directly beneath you. But on a cube, as you move away from the center of one of the faces, that's not true, because the center of gravity is going to be further from you as you move. So even though you are technically walking, on a straight, flat piece of ground, it's going to feel like you're walking basically up the inside of a bowl, because the center of gravity is going to be further and further from you.
Because it's not perpendicular to the surface.
Exactly, yeah. So even though you will be able to theoretically, just like see straight flat ground in front of you, it's going to feel like you're moving up a hill. But then things actually get even a little bit weirder than that. Because we sort of talk about how gravity isn't constant in the way you sort of expect it to be. Gravity also isn't going to be constant in an entirely different way that you would not expect, which is that gravity can't work the same. It doesn't work the same on a non-spherical object, because of the way that the mass of the object is distributed. So once again, if you're on a sphere, all the mass of the object is kind of below you at all times, basically. When you walk, I'll say up the side of a cube like this, the center of gravity is not necessarily going to be the way that the force of gravity pulls you because of the way because there's more mass below you as opposed to towards the center of gravity, if that makes sense. So what actually winds up happening is that it actually isn't as severe of a slope feel as it would be if that didn't happen. There's up to about a 14-degree difference between, basically what's going to happen is depending on where you are on the cube, the force of gravity is going to actually move more towards being straight down, up to about 14 degrees. So it's not as much of a bowl as it could be. It looks really weird if you graph it. I saw a graph of it. It's very strange, but basically gravity works really weirdly.
The way I think about it is if you are standing on top of a corner, gravity for you straight down, you're going to be basically looking at 3 45-degree slopes in any direction. It's like you're standing at the tip of a mountain. And so that would mean that gravity is 45 degrees off of what you the flat face. Mm-hmm. And at the center of it, it's perpendicular. And so in between 0 and 45 degrees, so what happens as you walk towards the edge of the cube.
Yeah. So how does that actually affect us aside from just, being weird? So the big thing is that it's going to affect how the fluids that affect our lives act, most notably, water and atmosphere. So those are both going to kind of pool at the center of the cube faces. So what's going to basically happen is you're going to have a big ocean with about a 695-mile radius. And then in sort of a concentric circle around that, an atmosphere bubble that's 1,700 miles. And everything outside of that is basically space.
Not basically space. It is space.
It is. Yeah. Space. It is. Basically space is wrong. It is space. That is space. So you actually can't just walk to the edge of the cube or the corner of the cube because you will die. But
you could theoretically go for a spacewalk.
You could in your own backyard.
Our space program would be easier, right?
Right. The space program is just a hike.
Yeah.
The space getaway weekend.
And then, so one really fun sort of thing that comes out of that I realized is that, so I sort of assumed that, the edges of the planet would wear down, but they really won't because there's not really any erosion because there's no anything. It's space. So the edges are going to be just barring, getting hit by something, just a straight edge, eternally, which is buck wild. And then the other big impact of the atmosphere thing particularly that has a very large impact is that, so technically, really, each face of the planet is basically its own, ecologically, its own planet. There's zero link with regards to evolution or anything between all of them. So beyond even just climate-wise biomes or anything, ignore all of that. Just evolution of life is entirely different on every face of the cube planet. Because so
it's going to be basically 6 different planets.
Exactly, yeah. Which is, once again, just buck wild. And most likely, life probably would not be able to evolve under these circumstances, but if it did on 2 of the faces, they would be entirely different. Entirely unrelated from each other, which is, once again, just absolutely buck wild.
That's a pretty awesome fact.
It is, right? Yeah, but I mean, it makes sense, because, once again, it's everything that's not in these bubbles is space, and things can't move through space. That's a pretty important part of science.
Also, what are how it took our society a long time to figure out that the Earth wasn't flat.
Right. Oh,
what
man.
the fuck are these people gonna think? Because they're you can clearly see it's flat.
Right. Exactly.
But it's uphill. All of it's uphill.
Well, and just the atmosphere is gonna keep thinning. So before you reach the end, you're just gonna stop being able to breathe. So what's that gonna do to your worldview?
Yeah. It just gets cold and you die.
Right.